Good morning, Year 5, and welcome back. It's day 3 of our last full week where we're talking about shape, space and measure again. Here are your answers from yesterday. Number 2, C, I did include another triangle question. Some of you may well have done a little bit of your own research and worked out how to calculate the perimeter there. Okay, so here is your Fluent in 5 for today. Pause the video. Give yourselves 5 minutes and restart for the answers. And here are your answers for today's fluency. Okay, today we're going to look at angle. We're going to look at angles today and tomorrow. So today is a recap really on the different types of angle that we might come across. Again, if you haven't watched week 8 videos, that might be quite helpful, and you'll see in a minute that I have got my angle measurer from week 8 as well. I'm just going to show you that. We're obviously not going to be doing any protractor work this week, but if you did want to make yourself an angle measurer, mine's just 2 pieces of cereal box, hole punch through them, and then I've used a paper clip to secure them. Please be careful if you do make your own, just so I can see whether an angle is smaller or bigger than a right angle. So, first of all, a recap then. Acute angles are angles that are less than 90. So a 90-degree angle is this one here, so the lines are perpendicular to each other. This angle is smaller, so we have to move the lines closer together. Okay, so any angle here between my 2 lines is going to be acute. I'm just going to draw a couple more so you can see a couple more examples. That's one. That's one, and all the way up to nearly 90. All going to be acute angles. Acute angles, angles less than 90 degrees. A right angle then, or a quarter turn, or 2 perpendicular lines is 90 degrees. An obtuse angle is an angle that's bigger than 90 degrees, but less than 180. So this is your 90-degree angle here. 180 would be here, 2 half turns. We'll talk a bit more about that in a minute. And an obtuse angle is somewhere in between. So that's one example. We could do another couple of examples here. Any angles which are bigger than a right angle but smaller than a half turn or a straight line. We'll talk a bit more about that in a minute. A straight line is 180 degrees. If you imagine I'm standing here and I'm looking that way, down that line, I'd need to do 2 quarter turns to end up looking that way down that line. So I'm doing a half turn, which is 180 degrees. This is a new one. I don't think we've talked about reflex angles before, but a reflex angle is an angle that is bigger than a straight line, but smaller than a whole turn. So you can see there, I've marked that on there. The other side of that reflex angle is an obtuse angle there, but it's bigger than halfway. So if I was turning my angle measurer, just do that like this, I've got to a whole turn, a quarter turn, a half turn, and then a little bit further. Okay, so that's a reflex angle. And 360 degrees, of course, is a complete turn. Just got a little recap of those for you so you can see. Okay, so a quarter turn here is 1 right angle or 90 degrees. A half turn is 2 right angles, 180 degrees. 3/4 turn is 3 right angles or 270 degrees. And 1 complete turn is 4 right angles and 360 degrees. Okay, so what we're going to do is we're going to look a little bit at certain types of angle and lines and how we can calculate the angle on them. So I've just told you that angles on a straight line is 180 degrees. Okay, so at the moment that angle is 180 degrees. What about if we divide that angle up? Let's just put an angle in here, and I'm not going to do any protractor work, so I'm just going to label the angle with an approximate. Let's imagine that this angle is 50 degrees and we need to work out this angle. Well, we know the whole of that line is 180 degrees. So if we were to draw it in a bar model, that's the whole turn, and we've got 50. The whole thing is 180. That's how many degrees are in a half a turn. We've got 50 here. How many would we have here? Well, I can see, because it's a bar now, I can see that I do 180 take away 50. So my missing angle is 130 degrees. Let's do another one. So this time, split it up a few more times, like so. Oops. Okay. So we've now split it into 3 separate angles. I'm going to just label them A, B and C. And I want you to imagine that A is 40 degrees, B is 80 degrees and C is missing. So we know that the whole line, the whole measure of turn is 180 degrees. We've got 40 and 80, and we need to work out that. So 40 add 80 is 120. 180 take away 120 means that part must be 60 degrees. So therefore that angle is 60 degrees. Okay, let's do one more of those. This time I'm going to put something in and I'm going to do it slightly differently because it doesn't have to be on a horizontal line. Okay, this time I'm going to do it a little bit differently. Okay, this is going to be 30 degrees and I want us to work out this one here. Well, it doesn't matter that my line is drawn on an angle. I could turn it paper around if I wanted to. I haven't labelled this one because I don't need to. Hopefully you can see that because I've drawn a little square there, that is actually a right angle. So the first thing I'm going to do is label that as 90. 90 add 30 is 120. And I want to make 180 altogether. So 180 take away 120 is 60, which means that that angle is 60 degrees. Okay, so that's a straight line then. A full turn is 360. So a circle has in it 360 degrees. If I now do this, okay, all of these angles are going to add up as A, B, C and D. Oh, I think A probably should have been that as well. They will all add up to 360. So angles in a whole turn or around a point equal 360. Okay? Now I'm going to tell you that I've got 2 right angles there and I'm going to say that B is 70 degrees. So we've got 90, add 70, add, we don't know, add 90. Okay, equals 360. So far, I've got 180, add 70, I've got 250 degrees. Oh, I've just realised that's ridiculous. Start again. Okay, so half a turn then is 180 degrees. One full turn, or complete circle, is 360 degrees. So if I divide this up like so, and we can work out a missing angle around a point. So altogether, these angles, I'll just change colour so you can see, we've got angle A, which is a right angle, angle B, angle C, and angle D there. And we could say that A plus B plus C plus D equals 360 degrees altogether. We know that A is 90. We don't know B. I'm going to have to give you B or C. So let's say that B is 65 degrees. C is 65 degrees. So B will keep as B because we don't know. C is 65. D is also 90 because it's a right angle. Equals 360. So far I've got 90 add 90, which is 180, add 65, which is 245. So I've got 245, add B equals 360. Okay, because A, C and D add up to 245, and then we've got B as well. So I'd need 55 more to take me to 300, and then 60. So 60 add 55 is 115. You don't have to, if you couldn't do that in your head, don't worry, you could have done a written method if you wanted to. So B is 115 degrees. We could add those back up and just check that it added up. We didn't necessarily need to do that, did we? Because actually you can see that we've got B and C there are going to add up to 180, so we could have done it that way. Let's do one more of those angles around a point, and then you've got some to do yourself. Okay, let's do it slightly differently this time. Okay, so we've got, let's do one more. Got 5 angles there, no right angles, not on purpose anyway. We've got angle A, angle B, angle C, angle D, and angle E. Now I'm going to tell you that A is, again, I'm just saying numbers, they don't necessarily correlate to the size of the angle. 20 degrees. B is bigger than 90, so let's make B 100 degrees. C is 80 degrees. And D is, oh, actually let's make C 70 degrees and D is 80 degrees. And E we don't know. So A plus B plus C plus D plus E equals 360. 20, add 100, add 70, add 80, add E equals 360. So far, 20 and 80 is 100, 270. And I've spotted already that 270 is a 3/4 of a turn. So actually E, in that case, would be 90 degrees. Now obviously, if I'd drawn it as, it's slightly out, but if I'd drawn it as a little square there, it would have been obvious straight away. So sometimes right angles are labelled with a curve rather than a straight line. If you do see a straight line though, you can know that it's a right angle. Okay, so over to you. If you want to make an angle measure to help you at any point, you can. Here is your task for today. Just a smaller one there so it all fits in. And I'll come back tomorrow with your answers.